Welcome to the fourth video in our options series. Now I want to look at the relationship between the value of a put option. Remember, put value is in equilibrium identical to the expected market price of the put. So put value, you can think of it as being the market price of the put option in equilibrium. We'll talk about disequilibrium circumstances in great detail later. So now we're looking at put value as a function of stock price at option expiration. Now, put options have two components of value, as you learned in the last video. One is intrinsic value, I'll now just note it as IV. The second is time value, I'll note that as TV. Okay, so the market price of a put in equilibrium is comprised of intrinsic value and time value. And for a put option, the definition of intrinsic value for the whole contract is the maximum of exercise price minus stock price, or 0, times 100. Notice it's X minus S now. For calls, it was S minus X. For puts, X minus S. Strike price minus stock price, or equivalently, exercise price minus stock price. And time value is, as it was with calls, is equal to the market price of the put minus the intrinsic value that we calculated right above. Okay? So time value is always what's left over. Now, again, this is going to be really stock price 1 minute prior to option expiration. We're going to consider that difference to be so small that it doesn't really matter because this gives us time to sell our option if we want it. If we hold our option through the moment of expiration, then we can't sell it. Then we have to get into something called exercise or assignment, which I'll talk about later. Okay? So put value, let's talk about a put option that happens to have a strike price of 45. So maybe we're talking about a 45 strike put on some mythical stock, HIJK, that is expiring in 1 minute. Okay, so as the owner of this put, you have the right to sell 100 shares of stock at a price of $45 a share. And our goal here now is to see at a point in time when the stock price 1 minute prior to OE is a bunch of different values as indicated on the horizontal axis. Well, if the price of the stock that, in this case, HIJK, is 45 or above, let's choose 46. Let's see what happens. Well, intrinsic value is the maximum of the strike price, 45, minus the stock price, right now assumed to be 46, which is minus 1. Maximum of minus 1 or 0 is 0, so it's worth nothing. What about stock price of 47? Well, again, we have strike price of 45 minus stock price, now assumed to be 47. The maximum of minus 2 or 0, 0, still worth nothing. Same for every stock price greater than or equal to 45. So I'll now indicate that with a green 0 slope line, beginning at 45 and going to positive infinity. And although I'm drawing the green line above the black line on the axes, understand that they are coincident. They are lying on one another. Now, what if the stock price 1 minute prior to OE was $44 a share? Well, intrinsic value would be 45, the exercise price, minus stock price assumed currently 44. 45 minus 44 is 1. The maximum, let me write that 44 a little better for you. 45 minus 44 is 1. The maximum of 1 or 0 is 1. 1 times 100 is 100. So here, the price will be 100. Well, let's now assume the stock price is 43. The price of the underlying stock, HIJK, 1 minute prior to OE. Well, go up here to our little formula and just change the value of S assumed from 44 to 43. The maximum of 45 minus 43 is 45 minus 43 being 2. The maximum of 2 is 0. It's 2. 2 times 100 is 200. So at 43 we have 200. And of course at 42 it would be 300 and so on. And then of course this isn't drawn to scale, so we have this. And interestingly, this line smashes into the vertical axis. Okay? And so there you have it. This is a value diagram. Again, this is a value diagram for a put option. Put value as a function of stock price at OE. In this case, the strike price of the put is assumed to be 45. And once again, we see this value diagram, in this case, put value diagram, as being composed of two linear segments, one with a slope of 0, the other with a slope again of the other with a slope in this case of minus 100. As we run, the run and the rise are in different directions. So as you can see, the slope of this line is obviously negative, but it's negative 100. Since it's a straight line, it's that slope of minus 100 at every point along that line. So there we see, I'll just draw it real quick, we see that as the value diagram for a put option. Just like that. And remember that we've looked at the value of the put, and in the last video, the value of the call as a function of stock price at OE. This is the simplest type of analysis to do because there's no time value involved. We'll see as we go through this series that time value is an incredibly complex and important aspect of option valuation. We'll see that we need to understand option valuation fundamental concepts before we can begin utilizing option trading strategies in an attempt to optimize our comfort with our investment portfolio. We're going to see later that options can be used to help us become more comfortable with our entire investment portfolio. And this will be the end of our 4th video.